Assalamualaikum warahmatullahi wabarakatuh. My name is Faris by Nizam from Group J for ECG263. So today in this video, I am going to show you how I perform water content test, particle density test, particle size grading and texture test, field density, and permeability test. Let's start with water content. So the purpose of this water content determination test is to determine the water or moisture content of soils. The water content is the ratio expressed as a percentage of the mass of free water in a given mass soil to the mass of dry soil solid. For many soils, the water content may be an extremely important index used for establishing the relationship between the way of soil behaves and its properties. The consistency of fine-grained soil largely depends on its water content. The water content is also used in expressing the phase relationship of air, water, and solid in a given volume of soil. So the material and apparatus that I use in this experiment is soil, tray, and digital scales. The first step is to split the soil into 3 parts. So I've split it into 3 parts. So now I am going to weigh the first tray, second tray, the third tray. So the first tray with soil, second tray, so the last one. So now I'm going to put all of the tray outside and let the drying process happen. After 24 hours of drying process, now I am going to weigh the first tray. The second tray, the last tray. So based on the result that I get, the water content for tray A is 23.9%, so soil for tray B is 17.3%, and soil in tray C is 20.9%. The average value of this soil is 20.7% water content. The water content for each soil in the tray is different because the area that has been exposed to the sun is different. So for particle density test, I'm using the method that is an improvisation of particle cyanometer bottle method. So the purpose of this test is to determine the specific gravity of soil particle of both fine-grained and coarse-grained soil. The determination of specific gravity of soil will help in the calculation of void ratio, degree of saturation, and other different soil properties. So the material and apparatus that I use in this experiment is a glass bottle, dry soil, water, and digital scale. First of all, we need to weigh the empty glass bottle. Next, we need to fill the glass jar with dry soil. Next, I will weight the weight of a glass jar with dry soil. After that, we have to fill the glass jar full with water. Now I am going to weight the glass jar with water and soil. Next, we need to clean the glass bottle and fill it with water. After filling this glass bottle with water, we need to weigh the glass. After that, we need to repeat the process 3 times. So as we can see, the result for the experiment that I obtained is the specific gravity for the first test is 1.55, the second is 1.57, and the third is 1.70. So the average specific gravity for the test is 1.61. So for the particle size grading and texture, I use the dry sieving method. So sieve analysis is used to obtain the particle size distribution of a solid material by determining the amount of powder retained on a series of sieves with different size apertures. This experiment aims to perform the differential of cumulative analysis of a given sample and to determine the particle population and average particle size of a sample by the case of a screen analysis. So the apparatus and material that I use in this experiment is 25mm sieve, 15mm sieve, 5mm sieve, and 2mm sieve. I also use digital scale, a tray, and a metal bowl. First of all, I use about 1000 grams of dry soil. So this is 25mm sieve, 15mm sieve, 5mm sieve, and 2mm sieve. Firstly, I use 25mm sieve. There is no soil that retains on the sieve. Next, I will use 15mm sieve. None of the dry soil retained on the sieve. Next, I use 5mm sieve. There are some soil that retain on the sieve. Next, I will use 2mm size of sieve. There are big amount of soil that retain on the sieve. Now I will weigh the soil that is on the base pan. The soil that written on 2mm sieve. Lastly, the soil that written on 5mm sieve. So as we can see from the result that I obtained in this experiment, the dry soil passed the 25mm and 15mm sieve aperture. At 5mm aperture, the passing percentage are only about 97.3. At 2mm aperture, there are about 35.1% that is retained at the sieve aperture. At the base pan, the weight of sample that is retained is 652 grams, and you can see that about 64.9% of dry soil that I use has passed all of the sieve aperture that I've made. So for the soil that is in the base pan, we can conclude them as a fine-grained soil. So for the field density test, I use the core cutter method. Field density test is a quality control test carried out at the site for knowing the increased density or compaction achieved at site on the soil layer. Field density test is a part of in situ soil testing, which is a broad subject of geotechnical engineering. The material and apparatus that I use in this experiment is soil, brick, 3 cans that have similar size, digital scale, and tray. First of all, we need to measure the height and the diameter of this steel container, 10.3 cm. Next, we need to weigh the steel container. Now we need to trim the soil. After that, we need to wake the steel container. After that, we need to repeat the same procedure for other steel container and let the soil exposed to the sun to let the drying process happen. Now we have to let it expose to the sun about 1 day to let it dry. And after 24 hours of drying process, now I am going to wake the steel container again. First container, second container, the third container. So from the result that I have obtained from this experiment, as we can see, the bulk density for the first set is 1.5, the second set is 1.59, and the third set is 1.64. And the dry density of soil for the first set is 1.44, the second set is 1.53, and the third set is 1.59. The average value for dry density of soil for all of the set is 1.52. So for the permeability test, I use the method that is an improvisation of falling head test. So the purpose of this permeability test is to find the permeability of soil. Permeability refers to the movement of air and water through the soil, which is important because it affects the supply of root zone A, moisture and nutrients available for plant uptake. The apparatus and material that are used in this experiment is soil, plastic bottle, water, and stopwatch. First of all, we need to cut the top of the bottle. Next, we need to make a few holes at the bottom of this plastic bottle. Next, we need to fill the plastic bottle with soil. Next, we need to compact the soil. To mark 4 levels at the plastic bottle. Next, what we need to do is we need to fill it with water, full with water, and let the soil fully saturated. Next, we need to fill this water bottle until the H1 level and immediately start the stopwatch to record the time. After it reaches H4 level, we can stop the stopwatch and repeat the same procedure with another set of bottle and soil. As we can see from the result that I have obtained, the first set takes about 38.1 seconds to reach H4 level from H1 level. The second set takes about 33.68 seconds to reach the H4 level from the H1 level. And the last set takes about 42.54 seconds to reach the H4 level from the H1 level.